Reflection. So reflection is a type of transformation that has a line in which the shape has been reflected from. So every point of the shape is the same distance from the reflected line as the corresponding reflected points in the reflected shape. So we'll get into this a little bit better, but here's a cheat sheet. So reflecting across the x-axis means the x values are going to stay the same, and then the y values become opposite. Reflecting across the y-axis, then, x values become opposite, and then our y values stay the same. So let's get into the first example. So triangle XYZ has the following vertices. So we have x, which is 1, 4, y is 5, 2, z, 4, 7. So first we're going to draw the triangle. Then if the triangle XYZ is reflected on the x-axis, what are the new coordinates of the vertices triangle x prime, y prime, z prime? So let's go ahead and draw the triangle. So we have x, which is 1, 4. So over 1, up 4. Then 5, 2. So 2, 3, 4, 5. Up 2. And then z, which is 4, 7. So we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So that's our z. We connect our triangle, and that's what it looks like. Not the most straight lines, but you get the point. So now what happens, right, if we're going to reflect it upon the x-axis, right, which is right here, we have y, 5, 2, z, which is 4, 7. So if we reflect it, we get x prime, y prime, z prime. Now what's really important is that the x values stay the same, right? We're gonna stay on the same x, it's just gonna change in the y value because they will become opposite. So what does that mean? Then the numbers will become, well, 1 is staying the same, but then it's -4. Y prime is then 5 and -2. Z prime is then going to be 4 and -7. So let's go ahead and draw this out. So x prime is 1, -4. So 2, 3, 4. Then we have y, which is 5 and 2, so a -2. So we go there. And then 4, -7 for our z prime. So 4, 2, 3, 4, 5, 6, 7. So you can see if we were just to fold it on this line, they would be aligned to each other. So we get our y prime, z prime, x prime. So when we look at this, we notice that the x for coordinates, right, is just 4 points up from this x-axis. And then it's just 4 points below. So they're the equal distance, right? And then y is just 2 points or 2 units up from the x-axis, and then y prime is 2 below, right? So we just changed the y value, made them opposite in the values. And it worked out because they're going from the x-axis, so they have to be equal distance. So that just means if it's positive, then it just becomes a negative number now. So let's do another example. Example 2. So triangle XYZ has the following vertices. So we have x, which is 2, 0, y, which is 4, 5, z, which is 6, 1. First, we're going to draw the triangle. Then in the triangle XYZ is reflected on the y-axis, what are the new coordinates of the vertices? So y is going up and down, right? That's our y-axis. So let's go ahead and actually plot these first. So we get 2, 0. for x. So here's our x value. Then 4, 5 for our y. So 2, 3, 4. 1, 2, 3, 4, 5. So this is our y. And then z is 6, 1. So 2, 3, 4, 6, 1. Now for this, now our y values are going to stay the same when we reflect across the y-axis, and then our x values will become opposite. So what does that look like? So x prime, and it's negative 2, 0, because our y values stay the same. Negative 4, 5. Z prime is negative 6 and 1. So let's just go ahead and plot that. So negative 2, 0. We plot right there. That's x prime. Y prime is negative 4, 5. So negative 2, 4, 4, up 5. Then z is negative 6, 1. And then we can go ahead and close the triangle. So notice how when we draw this, that if we were to fold it on the y-axis, it would just completely align. And this is just because, right, if you look at y, how many points away is it from the y-axis or units, right? So y is just going to be 4, right? So 1, 2, 3, 4. And then how many is it from this y? 1, 2, 3, 4. And why is that important? Well, because sometimes, like in the next example, we're going to reflect on y equals negative 1. So triangle XYZ has the following vertices. So we have x, 1, 1, y is 5, 1, and z is 3, 5. Now we're going to reflect the triangle, right? And then if the triangle XYZ is reflected on the y equals negative 1, what are the new coordinates of the vertices of the triangle XYZ prime? X prime, y prime, z prime. So if y equals negative 1, well, where's negative 1 for on the y? Well, it's right here, right? So this line. So kind of essentially is we're actually going to be, it's kind of like the x-axis, but we're just going to go down 1. But we can't use this trick here. And why is that? Well, it's because it's not across the x-axis like this here, right? This was crossing the x-axis. Now we're going across where y equals negative 1. So I'll show you the trick. So if x is equal to 1, 1, here's our x. Y is 5, 1. So 2, 3, 4, 5, 1. So this is y. And then z is 3, 5. So 3, 1, 2, 3, 4, 5. So now, essentially all we're doing is we're just moving it along the y-axis, right? It needs to be the same amount of units away from where this line here. So if x is 1, 2 units away, then we need to go down and go down 2. So we go 1, 2. And this is our x prime. Now, y is also 2 units away from this line, so we just go down 1, 2. Right, so notice our x values are staying the same. So this is y prime. Now, let's look at z. So z is 1, 2, 3, 4, 5, 6 units away. So we need to go down 6. So go 1, 2, 3, 4, 5, 6. And that's our z prime. And this would be our triangle. So you can see how we just went how many units away. The same rule applies. We're going to stay the same on our x values, right? So x prime is still going to be 1, But now we're down to negative 3. Y prime, still going to be 5. And then, as we see, we go down 1, 2, 3. So that's negative 3. And what about z prime? Well, z prime is still going to be 3. So we have to go over 3 and then down 1, 2, 3, 4, 5, 6, 7. And that's negative 7. And then there we go. That's our new vertices of the reflected image.